My name's Alex.
I'm Roberto Soto, I'm an ME.
I'm Skylar Miller, I'm an MA.
And together with help from our advisor, Dr. Rizzafi, we're group ReForm.
So just a quick overview of how we're going to lay out this presentation today. We're going to start with our problem statement. Then we're going to go into some background info so you understand some of the terms we're using in this presentation. Then we're going to go into shaping our knit no wire. Then we'll go into how we're sewing the shin splint sleeve all together. Then we'll go into testing, our ethics, our budget, and then we'll go into future considerations, our acknowledgments, and then our references.
So for our problem statement, shin splints are a very common injury among athletes caused by overuse that can cause swelling and weakness. An important note here is that a lot of the pain is going to be on the side of the leg. The main remedy currently for this is to apply compression via spandex sleeves. In order to solve this issue, we're utilizing a wire called knit null. And this type of metal has a shape memory property in order to create a consistent compressive force.
So currently on the market, there exist a couple of products. Very commonly, there are these elastic shin sleeves, but these are not custom fit. They're just usually a couple sizes, and they use elastic material. They can lose their elasticity over time. There's also KT tape, but this can be very difficult to apply properly. It's single use, and it's expensive. We're looking to fix some of these issues. Our target audience for this product is people who suffer from recurring shin splints, not people who just get them like once or twice from overexerting themselves that could use the KT tape that's single use. It's people who have this happen often, either from medical issues or from lots of exercise and working out in sports. We would like these to be recommended by trainers and professionals to these athletes.
So, knit null has two main things you have to take into consideration is a memory temp, which if you heat this metal at about 400 degrees Celsius, and you form it into whatever shape. So if it's a straight line, and then you heat it up to 400 degrees Celsius, and you coil it, when it cools back down, that will be its permanent temp. And then there's an activation temperature, which is much lower. In this case, we use about 77 degrees Fahrenheit, or about like about 25 degrees Celsius. Because we wanted to have it be activated by body temperature, and this is much lower than body temp. And we also wanted to be able to have your body transfer enough heat through a fabric to the metal itself, which is why we picked about a blend that would be considered around lower than body temp.
So here's a little video of us using the wires to kind of help you understand what's going on here. So we have this wire, which its memory shape is a straight line currently. So you're going to see me bend this wire into a shape, and then we're going to put it into hot water. And this hot water is going to heat up the wire to its activation temperature, and it's going to want to go back into its memory shape. So we're going to use that property in our sleeve.
Just a little bit of a life cycle, just to understand the process that we're going through to make this shin sleeve. We're going to be using a alginate powder to make a negative or an empty mold of, empty shape of your leg. And then we would then take that negative and we'll make a plaster mold of it. We would then go through the shaping process of our knit null so we can get the proper pattern that we need, the proper size for this person. Then we go into the sewing process in order to integrate the knit null with all the fabrics we're going to be explaining very soon. And then finally, we would just send this to the customer and obviously they can wear.
So to get this custom fit, we need something to mold the wire around. So we have to start by making a negative. We use a small trash can as a casting mold. And then, as you said, we use an alginate powder, which you mix with water. And then you have your leg in there, you pour it all in. The alginate powder mixture solidifies into a rubbery mold while you leave your foot in there for about 20-30 minutes. And then you can remove your leg from this rubbery mold. And then you can pour plaster of Paris into that negative of your leg and shin. That plaster of Paris is left to harden overnight. And then you can remove that hard clay-like plaster of Paris model of your shin from the rubbery mold. And then you have a model to
So here is how we heated up our wire to this high memory temperature. We had started off with our plan A, and we wanted to use current to put it through this wire to get it really high to heat it up. Unfortunately, we weren't able to get a high enough current in the lab to heat it up, but we did manage to heat up the wire. So theoretically, we proved if you could put enough current through it, that you could get it hot enough. But so we had to pivot a little bit and go to our plan B. So we surrounded this mold using an aramid fabric, which is super important here. It's preventing the mold from melting, it's protecting it. And then we pinned the wire using clamps. And then we heated up this wire using a propane torch. We did multiple rounds of heating and cooling, and then we took the clamps off to make sure we were getting the shape we wanted, and then made a better shape and then heated up again. It's important to note that on our final round, we heated it up and then sprayed it with cold water to rapidly cool it down to help it retain that shape. Here's a video of us just going through it. And then this is the aramid fabric right there protecting our mold.
This is the final shape we resulted with the nitinol. So as you can see in some parts, it is clearly not full turns. There is a gap there. That was on purpose because as we were going through our preliminary prototypes last semester, we attempted to do coils, and unfortunately we learned very easily that when you do a coil and you try to stretch up a coil, it's not going to really work out that well, especially if you're going to sew it and pin it at certain parts inside the sleeve. So we have to do these sort of like shell or half or partial rounds where we would do a clockwise turn, and then before we did a complete turn, we would pivot back and do a counterclockwise turn, which is why we had to pin with clamps when we were heating it, because it was very awkward positions and it was very frustrating to deal with, especially while it was trying to resist us actively, because its permanent shape at that time was a straight line. So we're currently building it at very small